We are entering part 3 where we are solving systems of equations. Now the first technique we're going to use to get an exact answer is substitution. Now compare this to something like graphing, where if you graph a line and then graph another line, you figure out where they intersect, you get kind of an approximate answer. You don't always know exactly where that's happening on the graph. However, with substitution or some of the other techniques we're going to look at next, like elimination, you can get an exact answer every time. So to take a look at this, we're going to start out with number 2. Our goal is to get one of the variables alone. And once we do that, we will then plug in its contents into the other equation. So of these two equations, I want to look for the easiest x or y to get alone. And I can see this, I have a negative 4y, negative 6x, positive 6x up there, but I have a y all by itself already. Whenever you have a y or an x without any letters or numbers by it, that is always going to be your easiest target. So you want to go for that one. So this is the equation I'm going to be plugging in for something else. And then this equation down below is the one that is going to get plugged into. So I'm going to rewrite this equation here, negative 6x minus 4, and when I get to y, I know what y is. Y is equal to 6x plus 21. So I'm going to plug in the value 6x plus 21 right inside of my parentheses right here. So 6x plus 21. And then I continue writing the equation up here, equals 6. So you'll notice everything about this is the same as this here, except I replaced y with what I know y to be, 6x plus 21. Because it says in my equation above, y equals that. So now I distribute my negative 4 and keep going with my problem. Negative 6x minus 4 times 6 is 24, and I have the x along, minus 4 times 21, and that's going to be 84. So 4 times 21, 84, and it's negative, is all equal to 6. Now I want to solve for x. I want to get x alone. I want to know what the value of x is. So I can combine my like terms over here to get negative 30x minus 84 equals 6. I add 84 to both sides, and I end up with 90 is equal to negative 30x. And when I divide both sides, I get my x value of negative 3. Now I'm half done. I got x, but my goal is to get a point, and a point is an x and a y coordinate. So I need to go back to my original problem and figure out what is my y coordinate going to be. The good news is that in the process of doing this, you already had to get y alone. So that means that you have an equation where you can very neatly plug in x, which we said was negative 3, into the x in the equation, and it will tell us y. So if we work out over on the side here, y is equal to 6 times, not x this time, but we plug in our value of negative 3, plus 21. So y equals negative 18 plus 21. And if we add those together, then y is equal to positive 3. So I zoom out here, and I look at my problem. I solved that x is equal to negative 3 and y is equal to positive 3. And when you think about writing a coordinate, you write an x comma y in parentheses. So you could say what I have highlighted here as your answer, or an even better way of writing it would be 3 or negative 3 comma 3, the x comma the y. And this point is your solution. Now we're going to zoom over to number 5, because number 5 has a few unusual things going on, and I want you to see different ways of tackling that. You'll notice here that I don't have an x or a y by itself, so I have to work a little bit harder in this one. My easiest target of the terms that I have here is probably going to be this last one, a negative 2y. That's probably the easiest to get alone of everything in this, but there's really no easy target. So I'm going to work on this one, and the first thing I'm going to do is I want to get this term alone, so I'm going to have to take 5x away from both sides. So I take a negative 5x, add it to both sides. And when I do that, those cancel out. Now I need to divide everything by 2. And remember, when you're dividing both sides, you divide every single term. So anytime there's an addition or subtraction sign between things, that is an opportunity to separate terms. So you need to divide all 3 of those things. 2's cancel, leaving me with y on this side. Here I have a negative 2 divided by 2, so that's going to leave me with negative 1. And then this last term doesn't reduce nicely. I have 5x over 2, or 5/2 x. So now I have y alone, and that will be useful for plugging into my other equation. One thing to be careful of is that you don't take your solved y and then plug it back into the equation you took it from in the first place, because you're going to find that's not going to work. You want to make sure you plug it into the other equation. So I'm going to rewrite that other equation right over here, and it's negative 10x minus 4, and I got y alone here, so I'm going to replace my y with what I know y to be. Negative 1 minus 5 over 2x. And then I'm going to keep going. So I have negative 10x, got that, minus 4 times what I know to be y equals negative 2. Equals negative 2. So I got all that. So now let's go ahead and work this out. We have a negative 4 distributed into these 2 terms. It's being multiplied by that, so it's distributed in there. I rewrite my negative 10x. My negative 4 times negative 1 is plus 4. My negative 4 times negative 5/2 x. That one's a little trickier. So I know that the negative times the negative is going to be positive. I know I'm going to have an x, but 4 times 5/2. It's kind of like saying 4 over 1 times 5 over 2. And I can reduce top to bottom. I have a 2 over a 1. So really I have 2 times 5 over 1 times 1. So 10 over 1, or just 10. So plus, and we said it's positive, negative times a negative is positive, 10, and then I have that x. So positive 10x. And that finishes up everything over here, and then equals a negative 2. When I combine my like terms on this side, I have 10x and negative 10x, so they go away, leaving me with 4 equals negative 2. Now, last time I checked, 4 does not equal negative 2. So I have a pack of lies over here. And I need to decide what to do about these things. When I go back to my original problem, when you end up with something goofy like this where you have an untrue statement, what you are going to say is you have no solution. So there is no point, xy point, where these lines are going to cross. That happens when you have 2 lines that are parallel to each other. So if you had the graph, these lines might look something like this. They will never cross, and the place they cross is the solution. So if they never cross, there is no solution. So whenever you see something like that, think no solution. The other possible weird case is when you get something like 7 equals 7, or 0 equals 0. Now that's a true statement. It's weird, it didn't give you x, but it is a true statement. So when you have something like this, you're going to say infinite solutions, because 7 equals 7 all the time, 0 equals 0 all the time. Infinite solutions. So no solutions when it's untrue, infinite solutions when it's always true, and then a single xy coordinate like we got in number 2 when you actually end up with x and y equal to something.